Roar! Let's do it, Grizzlies. Last section. Grab your 6.4b notes and let's get started. So this is now focused on the area of the surface that I'm spinning about the axis, whereas up till now we've looked at what's happening with the volume of the function that I spin about the axis. So we're not worried about the inside now, just the outside. So we're looking at surface area. So if you remember from geometry, the surface area, since I will be getting circles as I spin about, and so these circles will all combine to make a surface area. And so the formula for surface area of a cylinder from geometry was 2 pi RH. And so that's what I'm actually focused on. And now, the question I'm going to need to ask myself is, what is R perpendicular to? So, if R is perpendicular to the x-axis, then we'll integrate with respect to x. If R is perpendicular to the y-axis, then we'll integrate with respect to y. So currently in my picture, it looks like I'm drawing a radius that's perpendicular to my x-axis. So for this particular problem, I would want to integrate with respect to x. And of course, if I change it so that I'm spinning with respect to a vertical or the y-axis, then of course now all of my variables need to be in terms of y, including my radius, which this time would be perpendicular to the y-axis. So in this particular problem, I'm spinning with respect to the x-axis, so I would draw my radius perpendicular to the x-axis, which means I'm integrating with respect to x. So my radius, again, as in other problems, would be top minus bottom, and the top is square root of x, and the bottom is 0. So when I integrate, I'm going to get 2 pi times my radius, and then my arc length, and if you notice I went over there to the left and calculated my f prime, because I needed that for arc length. And then you'll notice that I left off the bounds, but if I go back and look at the bounds for x, well, it went as far left as 1 and as far right as 4. So I'm going to put this integral into my calculator to see what it totals, and I get 4.909, and if I multiply that by 2 pi, I get 30.846. Not a difficult process. Let's do number 2. So this time I'm spinning about the y-axis, which means I'll be doing dy, and of course I'll need my equations in x equals. So I converted it to x equals, and while I was here I got the first derivative, because of course I'm going to need that to plug into the arc length formula. Now I'm going to graph. So this time I'm drawing in my radius perpendicular to the y-axis. And in order to figure out the length of that radius, I'll need to do right minus left. But on the right, it touches my curve, which is the square root of y. And on the left, it touches 0. So when I integrate to find my surface area, I will substitute in first my radius, and then my arc length. So now I'll have to figure out my bounds for y. Well, I know the lowest y value is 0, but I have to figure out what the highest y value is. So I'm going to need to substitute in square root of 2 for x back in my original equation. And of course, if I do that, I will get just 2. After I integrate, I get this final answer here.